It started like any other quiet night in space. A faint object appeared in the sky, barely a whisper against the noise of thousands of stars. No alarms were triggered, no telescopes swiveled. It was just another speck in the galactic clutter, silent, fast, forgettable. But over the next few weeks, that speck did something no one expected. It brightened, rapidly, sharply, 5 times brighter in fact, far beyond what physics could explain. Then came the metals, nickel without iron, as if someone had forged the elements instead of nature itself. And all the while, it drifted into our solar system with a kind of eerie precision, ignoring the rules that comets are supposed to follow. Astronomers gave it a name, 3I/Atlas. But what it really is, no one can say for sure. Some now whisper the unthinkable. What if this isn't just another rock? What if it was made, not born? If you're drawn to mysteries where science brushes against the unknown, hit that subscribe button. You're going to want to follow this one. Let's begin with the night we almost missed the most unusual visitor our solar system has ever seen. On the night of May 7th, 2025, the Transiting Exoplanet Survey satellite, known as TESS, was busy doing what it always does, staring deep into the heart of the galaxy, capturing frame after frame of distant stars in hopes of finding new planets. Hidden within those images was something else. It moved just slightly from one night to the next, too subtle for automated systems to notice. A dim smudge weaving silently through the crowded star fields near Sagittarius. No alerts were triggered, no buzz spread across astronomy forums. It was just a ghost slipping by unseen. That ghost wouldn't reveal itself until almost a month later. On July 1st, thousands of miles away in the Chilean mountains, an array of telescopes called ATLAS caught something strange. A new object had suddenly flared in brightness, 5 times brighter than when TESS first recorded it. That wasn't normal, not for an object that far from the sun, not for anything we thought we understood. Atlas flagged it, the Minor Planet Center logged it. Within 24 hours, observatories across the globe pivoted toward this anomaly in the sky. Old images were dragged from archives. Data was reprocessed, frame by frame. Amateur astronomers jumped in, scraping through public records, stacking exposures, and mapping out the path the object had taken weeks before anyone even knew it was there. The picture that emerged was as clear as it was unsettling. From May to early June, 3I/Atlas had steadily brightened by a factor of 5, a surge no natural model could explain. And that was only the beginning. At first, astronomers thought it might be a glitch, a calibration error, a fluke of light buried in starfield noise. But as more data poured in from TESS, Zwicky Transient Facility, ZTF, and ATLAS, the numbers refused to back down. This object wasn't flickering, it wasn't pulsing, it was rising, smoothly, steadily, and too fast. Between May 7th and June 3rd, 3I/Atlas brightened 5-fold as it drifted inward from about 6.36 to 5.46 astronomical units, still far beyond the realm where sunlight normally triggers cometary activity. Under standard physics, a comet at that distance might brighten a little, maybe 50%, not 500%. Every major survey cross-checked its numbers against background stars, solar analogs, synthetic fields. The photometry held tight, with error margins below 1/10 of a magnitude. The light curve didn't jitter, it didn't spike. It simply rose with quiet persistence. There was no outburst, no sudden explosion of dust or gas, just a long, controlled glow, as if something had been turned on. And in astronomy, that kind of smooth, early brightening is weird. Some wondered aloud, could it be an artifact of motion? Maybe the object's true speed or angle had been misjudged, lost in the blur of Sagittarius. But recalibrations changed little. The curve remained. So did the puzzle. The sky had handed scientists a riddle that looked nothing like any known comet, yet acted exactly like something that wanted to be seen. And in the vacuum of natural explanations, a stranger question began to echo. Could 3I/Atlas have slowed down on purpose? While telescopes chased the light, spectrographs hunted for something deeper, the fingerprint of the object itself. At the Very Large Telescope, VLT in Chile, astronomers tuned their instruments to the faint atomic whispers coming off 3I/Atlas. Light from the coma, the hazy cloud of gas and dust surrounding the object, was split and stretched into spectra, exposing the elements it carried. What they found didn't just raise eyebrows. It violated chemistry, One element stood out clearly: nickel. Clean, well-resolved emission lines. Strong, undeniable. But something was missing. Something that's always there beside nickel: iron. In our sun, in asteroids, in every known comet, even in supernova debris, iron and nickel travel together, forged in the same stellar furnaces. The universe follows this pattern almost religiously, about 18 atoms of iron for every one of nickel. But in 3I/Atlas, the ratio wasn't 18:1. It wasn't even 2:1. It was something far more extreme, 15:1 the other way, or worse. Iron was gone, buried below detection limits. The team at Paranal Observatory, led by Dr. Sophia Cardenas, double-checked everything: calibrations, correction curves, lab references. Then they ran it again, and again. Nickel was real. Iron was silent. This wasn't just strange, it was unprecedented. Even the dustiest, most metal-rich comets in our own solar system had never shown anything close. Some tried to explain it away. Maybe nickel carbonyl, a fragile compound, had vaporized easily. But that didn't explain the absence of iron carbonyl, which should have followed. Others floated more radical ideas: selective sputtering during planetary formation, exotic chemical fractionation, or, what if, residue from an engineered structure. Nickel-rich alloys, eroded by heat or time, scattered into space like the ash of a dead machine. No propellants, no obvious fuel signatures, just nickel, standing alone, and the cold, quiet absence of iron. Whatever 3I/Atlas was shedding, it didn't match any natural body we've ever seen. It matched something else. By now, 3I/Atlas had a visible coma. A long, whispering tail stretched hundreds of thousands of kilometers behind it, classic signs of outgassing: dust, gas, vapor, all spilling off its surface as it neared the sun. That behavior? Typical. But what came next wasn't. In normal comets, outgassing acts like a thruster. Every jet of vapor pushes the nucleus slightly off course. Tiny, measurable nudges that astronomers call non-gravitational acceleration. It's basic physics. Mass leaves the object and the object shifts in response. But 3I/Atlas, it barely moved. From July through August, its trajectory remained almost gravitationally perfect, less than 1.5 kilometers of drift per day, despite all that visible activity. For comparison, 2I/Borisov, the last interstellar visitor with a strong coma, drifted nearly 100 kilometers per day under its own jets. That's nearly 2 orders of magnitude more. And this wasn't a measurement error. Every telescope, every data stack, every model agreed. The object was venting like a comet, but flying like a dead rock. There were only 2 options. It's absurdly massive, so heavy that even active outgassing barely shifts it. Or it's under control, stabilized, corrected, perhaps even designed to resist drift. Some speculated about surface features, like a shell, or internal mechanisms that redirect thrust. Others quietly raised a bolder theory: active guidance, a system built not to leave a trail, but to maintain a path. And in the silence between comets, it's the contrast that speaks loudest. Borisov followed the rules. Oumuamua broke them, with no tail, no outgassing, and a sharp, unexplained turn near the sun. And now Atlas, a full coma, but no turn at all. The rocket effect was missing where it should dominate, and present where it shouldn't even exist. 3 interstellar visitors, 3 contradictions, none of them fit the same mold. For generations, the search for extraterrestrial intelligence, SETI, focused on one dream: catching a signal, a narrow-band radio pulse, a laser flash across light years, something artificial rising from the background hum of the universe. The assumption was simple: if they're out there, they'll try to talk. And so we listened. But the sky stayed quiet. Decades passed. Telescopes grew larger, algorithms sharper. Still, nothing. Not a whisper, not a beacon, not even static that looked promising. Then, something shifted. First came 1I/Oumuamua in 2017, then 2I/Borisov in 2019. Now 3I/Atlas in 2025. 3 interstellar objects, 3 chances, and only one message. Maybe the signal isn't a transmission. Maybe it's a thing. In this new SETI, we aren't listening for voices, we're watching for visitors. Physical objects, macroscopic techno-signatures, can carry meaning long after a civilization is gone. They don't rely on timing or power or someone listening at the right frequency. They just arrive. A rock doesn't need batteries. A probe doesn't blink out after a few seconds. Unlike a fleeting transmission, a physical object endures. It can be studied, analyzed, intercepted. If it's built rather than born, it might hold information. And in that case, a single object is the message. So maybe the real cosmic conversation isn't happening over radio waves. Maybe it's drifting silently into our solar system, hidden among the comets. When 3I/Atlas first flickered into view, it wasn't the space agencies or the big observatories that cracked its secret. Not right away. It was you, and people like you, watching the sky from rooftops, backyards, and garages, armed with modest telescopes, open-source tools, and a stubborn curiosity. While major surveys combed through terabytes of data, amateur astronomers jumped in, pulling archived images from public databases, stacking frames, writing custom code to tease out faint trails. It was their work that helped reconstruct the early light curve, proof that Atlas had been active weeks before anyone sounded the alarm. On Discord servers and Telegram groups, word spread fast. There's something weird in Sagittarius. It's brightening. Go check your archives. From Pretoria to Perth, the world formed a makeshift network. Amateurs and professionals collaborating in real time, stitching together sightings from across hemispheres. Every frame mattered. Every timestamp filled in a blank spot on the timeline. And now, with the rise of next-gen observatories like the Vera C. Rubin Observatory, the early warning system is going global. Its Legacy Survey of Space and Time, LSST, will scan the entire southern sky every few nights, making it almost impossible for a visitor like 3I/Atlas to slip by unnoticed again. But telescopes alone aren't enough. It's the people watching, everywhere all the time, who turn raw data into discovery. The next anomaly could come tonight. The next interstellar visitor could already be on its way. And when it arrives, it won't just be scientists who see it first. It'll be all of us, eyes on the sky, chasing shadows, frame by frame. For weeks, astronomers held fast to the standard explanations. Instrument error, miscalculation, a strange but natural comet, misbehaving in a way we just didn't understand yet. But as the numbers kept holding, night after night, telescope after telescope, the uncomfortable question kept surfacing. What if this isn't just unusual? What if it's intentional? A five-fold brightening at a distance where ice shouldn't sublimate. A coma filled with nickel but missing iron. A tail that blows wide across space, yet a body that refuses to drift. No known comet acts like this. So what would? Some theorists quietly proposed a radical idea: controlled deceleration. What if 3I/Atlas had slowed down on purpose, not with chemical thrusters or ion drives, but with something more subtle? A braking maneuver executed far from the sun, matching its velocity to that of our solar system. No need for rockets, just a slow, deliberate alignment. It sounds far-fetched. It is far-fetched, but it fits the data. Of course, every extraordinary idea demands extraordinary evidence. And astronomy is a field built on caution, not hope. The cosmos has a long history of tricking us, turning cosmic coincidences into false alarms. So far, there are no fuel residues, no alien alloys, no blinking lights. But the contradictions remain, stacked up, unresolved, undeniable. And in the absence of proof, the question still hangs in the silence. If this wasn't built, why does it behave like something that was? Across the dark canvas of space, 3I/Atlas continues its silent journey. No radio pulse, no signal, just light, chemistry, and motion, and none of it quite adds up. It flared too soon, it shed metal in impossible ratios, it flew like it wasn't supposed to fly. No single anomaly proves anything. But taken together, they whisper a possibility we're not ready to dismiss. Maybe the first sign of alien life won't come in a message we hear, but in an object that refuses to behave. This isn't proof, it's a question. One written in numbers, light curves, spectrographs, and the quiet persistence of the unexplained. The universe may never shout, but every so often, it sends something drifting quietly across our sky. And if we're watching closely enough, we just might catch it. Subscribe if you haven't already, because this story isn't over. The next visitor could already be on its way.